Did I miss anything important yesterday?
Besides me,
Yeah.
we just did another formula,
Okay.
but I'll be putting that video up if I didn't put it up already today.
All right. Thank you.
You're welcome. All right. So the next formula, if we talked about the one we did yesterday, which is what you missed, Ashton, really, not me. It was this. That's a funky looking P. And the number of times that it compounds was our N. So if they say annually, we said 1. If it was semi, it was 2. If it was quarterly, whoop, there's a Y in there. It was 4. If it was monthly, oh, my cursive is terrible. There's an L in there too. It was 12, blah, 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 right? That was our N. Well, what happens if something is just continuously getting its interest or growing? What if something just doesn't ever stop growing? Well, there's a whole way that it came up, and it's actually in our book, and they can show you the numbers that they use to get to it. But there's this number E that pops up when something doesn't stop growing. And so it's called natural base E. Later on, we're going to learn about that natural log, but it has to do with E. And E is actually a number. It's very similar to the number of pi, meaning these two things happen naturally. They occur naturally in the real world, and we discovered them. No one made them up. So E is a number. It is not, and that number is about 2.718288459, and it keeps on going just like pi. It's an irrational number. But there's actually a button on our calculator that we're going to use. Normally it's found, and so you hopefully have a calculator by you. There's an ln button, and normally right above it there's an e to the x. Like on my calculators in class, that e to the x is in blue. And the reason it's in blue is because there's a blue second button. And what that means is this button right here actually has two functions. If you hit it without hitting the second button, it does the ln. If you hit the second button and then hit this one, it does the e to the x. So our formula today is called PERT. Kind of like the PERT test. But notice the R and the T are in the exponent's place. And actually, if you saw that button, it was ln, and then this was e to the x. So the x in this case would be our R times T. That would be our power. So what we're going to do is if someone says, Regina invests a $12,600, so that's what she invests, that earns 3.2% annual interest compounding continuously. As soon as I hear that word, compounding continuously, that phrase, this is the formula I'm going to use, not this one. As soon as I hear that it's continuously, I'm not using this one. This one goes out the door. This is the one that I'm going to use. So this right here, information they give me, is my P. This right here is not my R. I have to change that to a decimal, so I go and then get rid of the percent. Now that's my R. E is a number, it's not a variable. And then they say how much will be in the count after 12 years. So 12 years, I know that that is 12 is my T. So my formula looks like this: 12,600 E to the 0.032 times 12. And literally this is just plug and chug. So we're going to do this first. Then we're going to take e to that power using our calculator. Then we're going to take that number and hit it times 12,600, and we will have our final answer. So in my calculator, you should have a calculator out. You should be practicing using it with a calculator. It is your tool, and the better you get at using the calculator, probably the better you are in getting good test grades. So we're going to hit second, e to the x, and in my calculator, it looks like this: e with a caret symbol and then a parenthesis. This caret symbol tells the person that whatever follows it is the power of the E. So I'm going to put 0.032 times 12 in the parentheses. And the calculator is going to do this first. It's going to multiply this together. Then it's going to take E and put it to that power. And if I do that, I get now, hopefully you did this on your own. Now, if I put this and I times it by that, my answer is going to be off because I rounded this. And the more you round in a problem, the farther you are from the actual answer. So what I'm going to do is I actually am leaving. I don't do this very often. I am leaving this number in my calculator. I know that's kind of hard for you to see, but you see how much longer it is. So what I'm going to do is I want the calculator to put that. I don't want to write that number down. That's just too much time. So I'm going to hit 12,600 times second ANS. So there's a button on my calculator that says ANS. Can you guys see that? That is the answer to the previous problem that I put in the calculator. So it remembers this full number, not rounded, well, or rounded much farther along than I did. And so that answer is going to be much more accurate to the real answer than this one if I round already in the beginning. The more you round in the middle of a problem, the farther you are off from the answer. So I'm going to hit equals, and if I do, I get $18,498.63 is how much will be in that bank account. Does that make sense? Thumbs up? Something? Are there questions on that formula? All right, what's the key to tell me that I'm using this formula and I'm not using this one?
If it's compounding continuously.
Perfect. It'll be in the word problem. You will read those words. If it says annually, which one am I using? If it says it compounds annually, which one am I using? Go ahead, Kelly.
The original one, the A equals P and then 1 plus R over N.
And what would my N be if I said annually?
1.
1. If I said monthly, you would be using this formula again, but your N would be 12. So notice the different vocab is changing your N value. N is here, N is also there. So it's very important for you to know the difference between those two. All right, that's today's lesson.